All right, so let's talk about what we can connect this to in our brain also, because I did look up, I did finally get somebody to answer what exactly is given to you on the SAT as far as formulas and stuff are concerned. And I probably should have pulled that up to show you today, but I'll make sure you know what it is. But but the equation of a circle is not one of those things. Pythagorean theorem is. There's some other things that are. Hopefully we know what the Pythagorean theorem is without somebody having to tell us. But the formulas for volume and other things, they are on there. So I'll make sure you know exactly what you'll be given. But this is not one of them. So we've got to make sure that we know what it looks like. Also, because the SAT is a, gosh, it's not intuitive. I can never think of the word. Adaptive. An adaptive test, kind of like when you were taking the TSI. You can't go back. So it's not like you can say, oh, look, I can go back and look at the equation or move forward and find the equation and be able to use it if there's more than one question. So the equation of the circle is based on the distance formula. Now, chances are really good you don't know what the distance formula is. That's okay, because nobody ever really does. But here's some things that we should, hopefully somebody connected to you at one point, that the distance formula comes from the Pythagorean theorem, okay? I haven't actually spelled this out in a long time. Pythagorean, close enough. Theorem. And just in case, I don't want to know if you don't know because it might my head explode, but a squared plus b squared equals c squared. That's the Pythagorean theorem. That is something that is actually on the formula part of course, if you can't go back and forth, then how you get to maybe it's a drop down thing. I don't know how you get to the formula chart on the thing, but whatever. But that's the Pythagorean theorem. And they actually have it written. I mean, that's how we teach it. That's how you usually see it on the formula chart that you get or the reference materials. They actually have c squared in front equals a squared plus b squared. It's the same thing, but whatever. So Pythagorean theorem, if I was gonna review that with you from scratch, or if I was gonna show you the distance formula, we're gonna really talk about that. I'd show you how we get it from the Pythagorean theorem. But instead, I'm just going to put the distance formula up here. I think once I put it up here, it should look familiar to you. It's the big old crazy square root looking thing. And it is x2 minus x1 squared plus y2 minus y1. Not y, oh my goodness, I'm putting the 2 in the wrong place. y2 minus y1 squared. So does that at least look familiar to you? Like you've seen it before, right? Hopefully, yes. Okay. So it comes from the Pythagorean theorem because if I squared both sides, then I'd have something squared equals something squared plus something squared. And that's kind of where it comes from on that. So what happens here on your circle, and when you have it on a coordinate plane, here's your center, okay? And your center is in an XY ordered pair, but we use H and K. H is the X value of the center, K is the Y value of the center. This is some point on the circle, okay, so which we can just call XY. And then the distance between the two, what part of the circle is that? Somebody, anybody? The radius, very good. Radius goes from the center to any point on the circle. It's the same distance all the way around, right? Okay, so if we look at this and we think, okay, I'm going to use the distance formula here basically to get the radius. So the distance between the two is the radius. So I'm going to put an R here instead of distance. And then I'm going to have this big old square root thing. Right? So I have two ordered pairs. My X, X1, Y1, X1, X2, Y2, that kind of thing. So if I subtract my X's, if inside of here I can do X minus H, right, because those are my two X values, squared plus Y minus K squared. You see how I just substituted that stuff in? Now, you're not going to have to necessarily recreate exactly what I'm doing here. I'm just showing you where it's coming from because for some people that kind of helps you connect it in your brain. And then if I want to get rid of that square root, then I can legally square both sides. So what that gives me is that R squared equals X minus H squared plus Y minus K squared. Okay, and that basically is your equation of a circle. You could see it that way. Usually you see the r squared at the end, but it's the same thing. So you're just subtracting x values and squaring them, subtracting y values. It all just comes from the distance formula, and your radius is your distance. Okay, so the equation of the circle, the part of this that we really kind of have to know, and you get it in your brain, however, whatever works for you. The center is at HK, and the radius is r. So x minus h squared plus y minus k squared equals r squared. That is the equation, that is the standard form equation of a circle, which if they gave that to you on the reference materials, then it would make the other things that you have to do with it on the SAT maybe a little simpler, but it's not like it gives it away 100%. So it would be nice if they actually gave it to you, but they kind of expect you to know it. But again, if you have it tied to the distance formula in your brain, you know you're subtracting things, there's subtraction. And then if you also have it tied to the Pythagorean theorem, you know it's something squared plus something squared equals something squared. So you can get the minuses and the pluses in the right place. So what helps, okay? Everybody good with that? All right, so we're going to rewrite this equation a ton today because I truly believe that the more you write things, the more they kind of get stuck in your brain instead of just looking at, you know, something. So we have circle A with the center at 4, -2 and the radius of 3. So we're going to write down our standard form again. We're not going to be lazy. X minus h squared plus y minus k squared equals r squared. And to write the equation is going to be very simple with all the information that we have right now. I would suggest that we label our center with h and k. So we put them in the correct spots, right? And then obviously this is your r because it's the radius. So to do that, I'm just going to substitute it in here. I'm going to get x minus h, which is 4 squared, plus y minus k, which is a -2. And if I do y minus a -2, what does it really become? Plus 2, okay? Squared equals 3 squared, which is 9. And we're done. Okay? And that's it. The good news is you don't have to actually square these binomials. All right? And we just wrote that as the equation of the circle. So we got the information, we put it in, made the equation. We'll also look at some where we're taking it out, and then we'll also look at some where there's points on the circle. Okay? You're not solving for anything. No. We don't have to square anything out. We're not trying to solve for x. We're not doing any of that. It depends on what they're asking you for. Right here, it asks me to write the equation. Boom. That is the equation of my circle. I'm done. Okay? And the good news is, I know that on the SAT now there's some fill-in-the-blank questions. This would be difficult. I doubt, I mean, I don't know, but I doubt they'd have you type something like this. This is going to be more of a multiple choice, so I don't think you would end up going too far and solving when you didn't need to, that kind of thing. Okay. So then we get here. Let's write this again. X minus h squared plus y minus k squared equals r squared. So I kind of skipped a whole line of stuff that I could have written if I was being a little bit more careful, like minus a negative and 3 squared. We're going to write that here just because it'll kind of help us understand the next part. So I'm going to do, this is h and k, and this is r, right? So I'm going to get x minus 0 squared plus y minus a -3 squared equals 8 squared. Now this, I'm not solving, but I'm simplifying. What is x minus 0? X. So this is just x squared plus, and then since I have y minus 3, I have y plus 3 squared equals, what's 8 squared? 64. And then that's the standard form equation of the circle. Okay, so if they give you the center and they give you the radius, it's fairly simple. And I don't know that I saw any questions where it asked you to take this stuff and write it necessarily, but I think we did have to go the opposite way. But again, we have to understand this before we can do anything else. All right, let's go to the next part. So now it is asking us for an equation. No, because then you'll miss this. You're going to have to wait. It's asking us to write an equation. So we might have to do one of these where it passes through a point. So it's giving us a point on the circle and it's giving us the center. So what we don't have is the radius. We're going to start off writing that generic equation again. Because if we write it a million times, maybe it'll at least stay in our brains until next week. Then I'm going to label my points. Okay, the center is my HK. This point here is just some x, y. Just like we had on the front on that very first thing where we had the center and some point on the circle. So what we need is the radius. If I go ahead and substitute in everything I know, I can figure out what the radius is. I know what I have labeled as x is -2. Minus what I have labeled as h is -6. You see what I'm doing there? Squared. Plus y, which is 6, minus k, which is 3, squared. And that's going to equal r squared. Everybody with me so far? What is -2 minus a -6? That becomes plus a positive, right? So what do we get there? 4. So 4 squared plus 6 minus 3 is 3 squared equals r squared. Oh, what did I do? No, I didn't. No, it is not. Thank you for asking that. Because this is x minus h. This is x. This is h. Thank you for asking. You with me on that? I'm not subtracting these two because these are x, y. So it is -2 minus a -6. And then I did 6 minus 3, y minus k. Well, we're going to get a value for r, but then we're not going to be done because we still have to write an equation. But in order for me to write my equation, I have to have a center and I have to have the radius. We didn't have the radius, but I had a point on the circle and I had the center, so I can figure out what the radius is, and then I can move forward. Okay? So what's 4 squared? 16 plus 3 squared is 9, and that's equal to r squared, right? So then r squared equals 25. So what does r equal? 5, okay? And it's not plus or minus here, because remember, if you take the square root of both sides, you have to put a plus or minus. The reason it's not plus or minus is because the radius is always positive because it's a distance, okay? So now I have the radius, and I have the center. My suggestion would be that we then mark this out. And you're going to be doing an online test. I don't know that you can literally mark that out, but you probably had it written down. I would write down somewhere, or just make sure you're using the h and the k for the actual center. So using those two pieces and putting it in here, oops, oh my goodness. My first step would be, so now I would have x minus the h value, which is a -6, squared, plus y minus the k, which is 3, squared, equals r, which is 5, squared. Because I used the x and y to help me find r, but when I write the equation, the x and the y stay there. I replaced the h, k, and the r. So I marked that out so I didn't accidentally use those numbers. Does that make sense? Okay. And then when we clean this up a little bit, we will get x plus 6 squared plus y minus 3 squared equals 25. And I would imagine if this was a multiple choice question, obviously this would be one of the answer choices. I think another answer choice would be something that looks like this, but this is 5 instead of 25. And probably these signs would be different, you know, to make sure you're using the correct signs. And maybe even writing it with the XY instead of the HK, like all those little things along the way. Right? What questions do we have? We understand the process there? Okay, so let's do another one. They are giving me, again, a point on the graph and the center. So the center is HK. The point on the graph is XY. Labeling them so I put them in the right spots. Okay. I'm going to write down this even though I know it's right there. I've got X minus H squared plus Y minus K squared equals R squared. So this is the center, which I need to write the equation, but I also need the radius and I don't have it, but I can replace all 4 of these things so that I can find it. So I do X, which is 2, minus H, which is 2 squared, plus Y, which is 3, minus a negative 1 squared. That's going to equal R squared. Any questions about where any of that came from? All right, so what's 2 minus 2? 0. So I get 0 squared plus 3 minus a negative 1 is what? 4 squared equals R squared. So that means that 16 equals R squared and R equals 4. Any questions about where R came from? All right, you write the equation in the circle then. See if we can use the right information and get what we need out of that. Okay, that's what we should get in the end. Check yourself once you have tried it on your own. Does this stuff look at least a little familiar, like maybe somebody tried to teach you at some point? Okay. And then you don't use it at all. I mean, I get it. It used to be something that you learn first in geometry, and then you also do it in Algebra 2, and then you also do it in Pre-Cal. And then they took it out of Algebra 2 and moved it just to Pre-Cal, and then it's kind of out of Pre-Cal now too. So you really just see it in geometry, and then it's on the SAT. That's just kind of how it falls anymore, in Texas anyway. Good? Questions? Anything? Okay. So something else you might be asked is, if you have they give you an equation. There's the equation of the circle. And then they ask you for the center and the radius. So still a good idea to write down the equation because if this is my equation, is H 3? What would H have to be? -3. So your center, which is HK, it is, since this is minus, so I'm writing it down to remind myself, this is a minus, so this has to be a -3, and what would K be? 5. And then this, oh, I put 4 there, dang it, what I meant to put there. Sorry, I was trying to, is R squared. So since R squared equals 4, what's the square root of 4? 2. So the radius is 2. Okay? So you've got to be able to go the opposite direction as well. Okay? What questions you got? All right. Good deal. So then let's look at this one. We're going to write it again just because we need to write it a million times. X minus H squared plus Y minus K squared equals R squared. That is one way to kind of learn something without like memorizing. Memorizing is just, if you write it every time you need it, it just kind of becomes second nature. So if this is true, and we're using these two together, and I need the center, what do you think the x value of the center is? -7. Very good. What would the y value be? 0. Very good. And then the radius would be the square root of 48. Now, one of the things that is kind of within the stuff that we are going to review is simplifying square roots, because that is the skill that we need, whether we need it for the SAT or the TSIA or for college algebra, still need it. 48 is not a perfect square. There are different ways to teach how to simplify this, and if it is something that you're already good at and you don't need a way for somebody to kind of, do it your way, that's fine with me. But here's what I would suggest, is that we start with like a little factor tree. And it does not matter what two numbers you start with, just what are two numbers that multiply to give you 48? 2 and what? Oh, 12 and 4. I thought you said 2 and then 4. I was like, what? Okay, sorry. That's why I kept looking at you like, what? All right. I heard 12 and 4 for, actually, that's not what I heard, but she was the first one to speak. I don't know what I was hearing. And it's okay. I was like, what? 2 and then 4? That doesn't make any sense. Okay. My bad. That was my fault. Okay. So then neither one of those are prime numbers, right? What are two numbers that multiply to give me 12? 2 and 6. Okay. 2 and 6. And I could have used 3 and 4, like it doesn't matter. But when you're doing the little tree, when you get to a prime number, I circle it, because that's like where that little branch stops. And then 6, I only have just 2 and 3 are my only choices there, right? Now, once you understand it better, you can not necessarily do this branch, but I'm going to go back over it like maybe we really need a lot of help with it, and who knows. But the safest way, I think, 2 and 2, so I've got all my prime numbers. And if they're circled, then I know I ignore everything else, right? And if I'm taking the square root, then I look for pairs. I take out 2 2's. I'm going to cancel them out. They come out as a regular 2. This 3, he doesn't have a pair. He stays in the house. These 2 2's come out as a 2. And then you multiply everything back together, and your radius is actually 4 times the square root of 3. Okay? So here's the good news on the SAT, is that you have access to the calculator for every single question. So if there is a question where you have to simplify a square root, you can always just kind of check your answers, but you got to know how to do that correctly. Whether you're checking it by hand or you're checking it with the calculator from the answers, if you have this and you want to know whether or not it's the same as this, you take whatever's on the outside and square it, multiply by whatever's on the inside. So 4 squared is 16 times 3 gives me 48. And that's the way you can work backwards if you need to work backwards, okay? Still a skill we have to have, but I'm sorry, go ahead.
This is kind of like unrelated, but like,
no.
Did they get rid of the non-calculators?
Yes. So now, since it's digital, you have access to that Desmos for the whole thing.
Oh, wow. So
yeah. Exactly. So, I mean, it sounds good because like, ooh, but truly, you can work every single question on the SAT without a calculator at all. Like it's not, there's nothing that requires the use of a calculator, which also tells me like that the trig stuff is really just about ratios, not about really solving it. But yes, but if you had to do it by hand, like if I said we have 2 times the square root of 5, and I wanted to know what did I simplify to get that, I square 2 and get 4. 4 times 5, that's the same as the square root of 20. I mean, the skill we need is to go from here to here, but that's also how you check yourself. Okay. We good on that? What other questions you got? That was not unrelated. That was a good question. Okay. All right. More circles then. I don't know that you're going to have to graph it, but it is possible that you might have an equation and then you have to match it to a graph. So let's make sure we know what to do with that. The first thing we have to do is take out the center and the radius just like we did on the last questions. So for A here, what would the center of this circle be? 0. Okay, so 0, 0. And what would your radius be? 5. okay? So then when we're going to go to graph that, you plot the point for the center. And then from the center, remember the radius is the same all the way around. You're not literally going to have to graph it yourself. So as long as you know how to figure it out, you can't really count diagonally accurately. So we go to the right 5, go back to the center, to the left 5, back to the center, up 5, back to the center, down 5. And then if you did have to sketch it at any point, you just do your best. And if it kind of looks like an egg or whatever, it doesn't matter because it's not an art class, even if you have to draw it. And as long as you get the idea so that you can figure out what it is, okay? Because you should be able to, like I said, if they give you one, match it up. Or if they give you a picture that you can find the equation, that type of thing. So let's look at B. What is the center here for B? -1, 2, good. And what's the radius? 3, okay? So we're going to plot -1, 2. That's the center. And you might even want, well, I mean, you're not graphing it, so it doesn't matter, but I'm going to label it as the center so I know where to go back to. Then from the center, I'm going to go to the right, 1, 2, 3, make a point. Go back to the center, go to the left 3. 1, 2, 3. Go back to the center, go down 3. Back to the center, up 3. And then that would be the basic circle you're trying to find. Okay. What questions do you have? This is silly? Yeah. Yeah, it does. It looks very complicated, but look how smart you can, like when people think it's complicated, you're like, oh, this is a piece of cake. I don't know why it's so hard for you. All right, we good? All right, so one of the questions I did see on there, which is another type of, hey, here are some points, is that here it gives us the equation of the circle with the endpoints of the diameter being these 2 points. Now, the radius goes from the center to any point on the circle. Where does the diameter go? All the way across, and it has to go through the center, right? So with this information, I can find the center, all right? And so I need to find the center, which is really easy, but let's think about what this is. Let's go back up here and let's just look at, I mean, we know what the center is and everything, but so this right here, this will be my diameter, yes? So here are the endpoints of the diameter. Where is the center in relation to the endpoints? The middle, exactly. It's in the midpoint, okay? And so there's an equation for how to find a midpoint also, but we don't have to overthink equations. If you have a piece of string and you want to find the middle, the easiest way to do it without measuring, right? You take the 2 ends, you match them up, and then you take it in half, right? Like that's how I would find the middle of anything. So that's what I want you to think about doing with these points. These are the endpoints of your string, right? So you're going to take the 2 endpoints and you're going to put them together. So when you do that, you're going to take your 2 x values, -3 plus a -7. I'm adding the endpoints together. And then, so x plus x, because this is an xy, and then 8 plus a -6. And then you divide them both by 2. That's how you find the midpoint, okay, of a line segment. You add the 2 endpoints together and you divide by 2. Always make sure you're adding x plus x and y plus y, because this is an xy thing. So then this gives me -10 over 2 and 2 over 2, right? Which means the middle of the 2 endpoints of the diameter will be my center, and it's at -5, 1. That's the center of the circle. Everybody okay with that? So just think about a piece of string. Don't overthink. I mean, I can give you the equation. The equation of a midpoint, 2 divided, so 8 plus -6 is 2. 2 divided by 2 is 1. It gave you the 2 endpoints. So what it's giving us basically, it's giving us these points. I mean, obviously it's a different circle, but giving us the endpoints. We need to find the center so that we have the center and a point on the circle so we can write the equation, okay? And just FYI, the midpoint formula actually looks like this. It's x1 plus x2 over 2 y1 plus y2 over 2, but they're not giving you that on the reference sheet either. But that's just bringing the endpoints together and cutting it in half. Just think about a piece of string. Okay, the diameter is a piece of string. That's what we're doing. Okay, so we found the center. Now, back here, we had the center and a point on the circle, right? We just took 2 points on the circle to find the center. So now that we're here, we're basically going to be able to do what we just did using the center and one of the points on the circle. It does not matter which one because you will get the same answer in the end. If it were me choosing, I would choose the first one because it only has one negative and I have less chance of doing weird things with negatives. And that's the way I usually look at it. But it does not matter either way. So I'm going to use this one, which means I'm going to mark that out. And because I have so many points and I have, they do different things, I'm also going to label, say this is my center, so this is HK, this is XY. The more you do those simple things that I know a lot of you don't like to do because you think you're going to run out of lead or something, I don't know. But it keeps you from doing weird things sometimes. So now we're back where we were on that other example. That means that I'm going to write down my equation, x minus h squared plus y minus k squared equals r squared. To actually write the equation, I need the center and I need the radius. I have the center. I can figure out the radius by using a point on the circle, right? So just like I did before, x minus h, so that's -3 minus a -5 squared. So many places to make a mistake with signs. Plus y minus, oh, why did I put a y? I'm sorry. Y, my actual y value 8 minus a negative, no, oh my God, I'm just making stuff up. Positive 8 minus 1, there we go, equals r squared. So -3 minus a -5, that's 2, right? So 2 squared plus 7 squared equals r squared. So that's 4 plus what? 49 equals r squared. So that means that r squared equals 53. So r equals the square root of 53. And can we simplify square root of 53? We don't care. Here's why we don't care. Nobody asked me for the radius. I had to, what'd you say? Is he over here doing it? Good job, can you? I think it's, oh, you did it wrong. I think it's a prime number, but, okay, it's a prime number. But even if I could, let's say we got square root of 48 here. Yes, we can simplify that, but we don't need to here because we weren't asked for the radius. We're about to take this and substitute it back in here and square it anyway, right? So we're just going to undo it to do it back. So as long as we get that far, we're fine. So now I have the radius. I have the center. Those are the pieces I need to use this. So again, if I was doing this on strictly paper, I would now come up here and mark that one out so that I don't accidentally use those numbers because we got numbers everywhere, right? So even if we don't have great handwriting, try and keep your work organized when all you have is scratch paper is important so you know what's what and you don't just have random numbers that you're doing stuff with. Okay, so now I put this in here using this. I've got x, and remember I'm replacing h and k and r. So x minus h, which is -5 squared, plus y minus 1 squared equals the square root of 53 squared. So when I simplify that up, I should have x plus 5 squared plus y minus 1 squared. What is the square root of 53 squared? 53. Okay, and we're done. Okay? That sucked. There were lots of steps there, but I did see an example like this. And remember, this is an adaptive test. Now, On the Albert stuff, you can't see what they're ranked as, like easy, moderate, difficult. I took out the difficult ones because they're kind of out there and I didn't want them to stress you out. You know what I mean? If we can get through the other ones, we'll be fine. And if you can get through those on the test, that's great. But I took those out. This one is a moderate. Yeah. It's not the difficult one. The difficult ones, you have to complete the square and do other things that, honestly, you would have needed to see it again in an Algebra 2 setting or a pre-cal setting to have gotten that far. Like, you weren't taught that stuff, so it's not your fault. It's just, you know. I'm not going to try and do it the week before when I'm also trying to review this stuff. It's just too much for everybody, okay? Just too much. But here's a good thing. I saw examples like this too, and this is actually easy, super easy. So, and you don't have to know the equation or anything. We're just trying to figure out, are these points on the circle? Now, you could graph the circle. Nobody's doing that. Don't do that. That's the hard way to do it, even though it might seem simpler. If I want to know if this is a point on the circle, this would be x, y. So all I'm really doing is substituting it in. So if I substitute it into this, I would get x, which is 2, minus 4 squared, plus y, which is 8, minus 6 squared. And then we have equals 8, but what we're trying to figure out is, like, that's a question mark, by the way, does it really equal 8? If it does, it's a point on the circle. If it doesn't, then it's not, okay? So what's 2 minus 4? Negative 2. So negative 2 squared plus 2 squared, and does that equal 8? Well, what's negative 2 squared? 4. So this is 4 plus 4. Does that equal 8? Yes. So this is a yes. It's a point on the circle. Okay? See how easy that is? Not bad at all. So then if we do that again with this one, I'd have negative 3 minus 4 squared plus 5 minus 6 squared. And then I want to know, does that equal 8? Well, this would be negative 7 squared plus negative 1 squared. Does that equal 8? And can you figure out if it equals 8 or not before you even finish? Yes. So this is a no, and you don't have to always go and finish the entire thing if you can figure it out along the way. Okay? What questions do you have? Okay, so the good news about Albert is that you can skip around, okay? I'm okay with that. I want you to actually honestly go in there and use it to your benefit, okay? That's my goal. It's not about getting a grade. I think I've hopefully proved that to y'all already.